Hello everybody, today we're talking about our project. In today's presentation we'll start with talking about general information about stone, including history, types, stone choice and other characteristics. Then we will move on to talk about our main premise in that project, which is marble and granite. We'll talk about their different kinds and we will compare them to each other. Finally, we'll talk about how they are manufactured and how they are installed. It is important to note that all the participants in that project are architectural students, and there are some architectural scope added to the project. However, we understand that this is a construction course, therefore construction should be the main theme. Before moving on, I would like to say that this project has been created as a result of the collaborative efforts of Ahmad Noor, Abdullah Zufar, Marwan Wafi, and Sirajuddin. Now it's time for us to talk about the history of the material. At the beginning, it's important to know that humans used to build with what is available to them, what is surrounding them, what is in front of them. A concept we now know as vernacular architecture. For instance, in Mesopotamia they used to build with mud bricks because of the muddy environment they used to have. In the United States and the United Kingdom they used to build and still build to some extent with wood because of the plenty of wood available to them. In the UK they also used to build with stones because of the mountains they have in some areas like Wales. Here in Egypt we used to build with stone because of our desert environment. And because of that, much of our heritage, culture, and knowledge about the past is still preserved till this day. Since it has been used since the Pharaonic age, stone is definitely one of the oldest materials in construction, along with mud bricks of course. It was used to build ancient buildings like the pyramids in Giza, Peria Chamber in UK, and Malta Temple. The first type of stone structures was based on stacking stones above each other and using its own weight as a sort of the binding material of that structure to keep it safe and stable. Then the technique has developed to include some sort of a mortar, which included mud and water. Then the technique has developed to include cement and water and sand. Along with its structural capabilities, there is definitely some beauty element associated with stone. For instance, materials like marble and granite has been used widely in Roman architecture, Islamic, Catholic, and palaces for its decorative features. Nowadays, because of its value, because of the ancient and how it is submerged in our culture and how comfortable it feels, we appreciate mostly the stone because of its beauty, because of its texture. So we use it mainly as a cladding material because of the advancement we now have in the form of concrete constructions. It does feel comfortable, like I said earlier, because of its value and submergement in history. It's not like steel structures and glass structures, which can kind of feel like art. It has been favored here in the country because, quite frankly, it is available. Now moving on to the different types of stones available. When we talk about stone, we talk about one of the most diverse and general materials available on Earth. There are plenty of ways to classify stone. One of the most general and broad classification of stone is according to where they come from, and it goes as follows: igneous stone, sedimentary stone, and metamorphic stone. Igneous stone is made basically from the volcanic eruption, and such stones include granite. Sedimentary stone is made because of the decomposition of organic material. Such stone include limestone and sandstone. Metamorphic stone is made under huge pressure. Such stones include marble. Other classifications may include color, texture, hardness, resistance, and many other characteristics. Now, what are the different types available here in Egypt? In Egypt, we have a lot of stone materials and range of products. However, mostly they are for decorative and cladding purposes. Such material include imported marble such as Rosa Levante, Equator, Indiana Onyx, Crema Valencia, and some also local marble such as uh, Trieste, Royal Beige, Golden Sinai, Galala, and some important granites such as San Francisco, Indiana Giovanna, Colombo Gold, and many others. There are also some local granites such as Red Aswan, Rose al Nasr, Karnak Grey, and also many others. There is also Hashma stone. The Hashma stone is a beige colored stone that is used in cladding a lot of buildings such as AUC facades for instance. There is also sandstone, limestone, and basalt stone. There are some engineered stone which is synthetic, and also semi-precious stone which is also synthetic. Now it's time to talk about the characteristics that combine all that wide range of products under one umbrella. These characteristics are the common characteristics between the entire range of products of stone. The factors. The first characteristic to talk about is the heat properties of stone. Stone features high specific heat capacity, which means it takes a lot of energy and heat to raise the temperature of stone by even 1 Celsius degree. Hence, the buildings that are made of stone are actually much cooler than the surrounding buildings and other concrete structures or the surrounding environment. And this is a property of high thermal mass that is one of the main concepts and principles used in green architecture and environmental architecture. The second property that we are going to talk about is sound properties, and stone is one of the best insulations for sound. One, because the walls are actually quite thick that sounds don't normally go through it, and second, because of the non-directional fiber orientation of stone wall, it helps to absorb the acquisitive waves that can reduce the intensity and the propagation of noise. The third feature is the compressive strength of stone. The stone is basically a brittle material, and like all brittle materials, it features high compressive strength. It is perfect in compressive forces. It can withstand a huge amount of force in that genre. However, in that its tensile strength is quite poor. It has a very low tensile strength that is neglected in most structures because of the factor of safety. Stone also features a lot of durability, is able to maintain and endure its essential and distinctive characteristics like no other material, and that's why its structures can remain for thousands of years. The maintenance. Stone actually has the ability to be restored to its original state at any moment just by polishing it. It is a very simple process and the results are magnificent. As we have mentioned earlier, there is a wide range of variety of materials. So what makes that type of stone perfect for that use, and why that type not the others? Well, it differs according to certain characteristics include color, wall texture, light and dark, hardness and resistance to weathering, density, availability, and cost. Moving on to the first consideration for stone choice, which is color and texture. As you can see in the slides, there are a wide variety of colors even for a single type of stone. As you can see in the slides, the different colors that is exhibited by even a single type of stone, which is limestone. You can see the color ranging from bright yellow to brown to green bluish, and that is amazing. You can also still see the different textures it is easily recognized through even those pictures, and definitely gives different textures to the wall and to the building. The second factor of stone choice is the wall texture, how we want the wall to feel. First sub-factor that affects the wall texture is the type of stone. What type of stone and what subtype of stone we want to use, and each type gives us different texture. The shape of the stone, whether it is round, rectangular, irregular, what other shape it might have. The technique of building the wall, whether it's ashlar wall, which is using the wall which is neatly stacked, accurately stacked to give a very closely stacked square stones, whether it is a rubble wall, which is just putting the stones randomly with no or little shaping occurring to the stone. The third factor that we need to care about when choosing the stone is the resistance to weathering, especially when it is an outdoor stone, because an outdoor stone needs to be resistant to weathering, need to be resistant to fluctuating temperature, leading to resistance to alteration, moisture, induced expansion. All of those factors can deteriorate the stone wall quickly and deteriorate the building very fast. Also, the final factor to be considered is the cost and the availability, because every project has its own budget, has its own time frame. We need to care about those things, and also in terms of availability, when the stone is readily available, that means less transportation, that means less fuel to be exhausted, less fumes to be exhausted as well. That means it's more environmentally friendly, which might be the policy of the firm or the construction company constructing that building. As we have mentioned earlier, there will be some architectural aspects that is considered in that project, and first architectural aspect is the stone architecture itself. What are the limitations of the material and how that affects the design? Such factors include legislation, edge corners, load bearing, size, strength, span, and windows and doors. The first factor to be considered, as it is limits the design, is the legislation. In some countries it's hard to get permits for stone structures beyond 2 floors. It is always a must to get a building surveyor to be satisfied with the strength of the stonework foundation. The building needs to satisfy certain standards, and such standards include span, robustness, strength, and bending and shear. There are a lot of equations available in certain standards, which basically are international standards that need to be satisfied for the structure to be safe and sound. Other factors that need to be considered while designing is the shaping of stones. Shaping of stones is a very effortful process, hence time consuming, hence costs a lot of money. Most stones don't actually break at a 90-degree angle, therefore designing those sharp angles is very hard to do and should be avoided if possible. Designing at angles that the stones actually break at is more favored and more respected in the terms of design. Round corners might be the most economical solution, and quite frankly it looks quite pleasant. Another factor and very important factor to consider while designing stone, that the fact is stone structures are load bearing. That means there is a size strength effect. Load bearing structure means that the walls actually carries a building. When the wall carries a building, the walls are structural elements. That means it is always helps the structures to have a lot of interior walls. Hence open plan designs cannot be implemented, therefore modern designs are usually not created with stones. And also that means it is usually best preferred to use stone structures and load bearing structures in residential where there are a lot of interior walls and partitions. Also, in terms of the future of the building, you cannot amend the walls or you cannot amend the structure or the plan or the design according to a future need or a future requirement. And also, because the walls are carrying the structure, that means the walls need to be thicker than concrete structures where it can reach 250 millimeter max. In fact, stone structures has a wall reaching 300 millimeter with a single floor structure, and it can reach to 400 to 600 millimeter if the apartment or the structure became a 6-floor structure, and that is very constraining in terms of the design. One of the most important factors to consider while designing using stone is the span or the roofing system. Using a lintel system is very constraining because it's very weak, it's very inappropriate because stone has a very low tensile strength. That means it breaks at a very low bending moments. Therefore, we cannot have very large spans, as well as although we can use other systems like reinforced concrete for roofing, it's also best to use walls, domes, or arches to achieve very large spans, and it gives, quite frankly, original feeling and authentic design. The last factor to be considered while designing is the openings. Any opening means a weakness in the structure. Therefore, we cannot have large openings or curtain walls like most modern designs require. The percentage of opening to solid is quite low, and windows and doors should always be aligned so that we have the line of weakness aligned, not scattered throughout the structures. Windows are also preferred to be high so that the opening of the window is only carrying the roof or the ceiling of the structure rather than the entire floor. Why marble and granite? Well, basically stone is a very general and broad term that no single research can study every single type of stone thoroughly, and also because of the popularity and the commercialization of the material, stone, marble and granite actually have a very distinct decorative features that is loved and wanted in every apartment, most palaces, most villas than we actually require. Also, the availability of the material is quite available in the country. There are a lot of factories supplying and a lot of workers working on that area and that genre. The globalization of the material is also another aspect. The material is exported and imported throughout. As we have said, we have range of imported marble and range of imported granite throughout the world, and we are appreciate the natural stone effect, and also because of the introduction of reinforced concrete structures that enables us to build with skeletal systems. That means open plans design that is easily amended according to future requirements and future clients, and also that means we can reach very high floors with no or little restrictions, and also and therefore the stone structure as a structures has been scarce throughout the modern age. The need for an open plan, as we have said earlier. Here we are showing you the range of products available in the genre of marble, both imported and local ones. We have taken that list from a catalog from George Abdullah's factory, and we wanted to give you samples which actually obtained from the factory as well. And here are the range of products of granite which also we obtained from the same factory, and also it shows a list of important and local granites that are available right now in Egypt. Now it's time to compare the different types of marble. Quite frankly, there are a lot, and I mean a lot of marble types that are available right now in Egypt, each with a different compressor, each with a different density, with a different color, with a different hue. We have selected a few here and made a compressor. We made a thorough analysis and a thorough comparison. Here we have a marble called Samah, which has a compressive strength of 130.5, 2530 of density, and it costs like 450 per square meter, and it's used for tiles and stairs. And we also have like golden cream vein, which has a compressive strength for 101, density of 2669, cost per meter square is 450, and is used for paved slabs. We have uses for paving, interior tiles and tabletops, flooring walls, and many other uses that makes marble a very important. We have done the same for granite. We have selected few granite materials and we have made a comparison between those. We also have a range of compressive strengths ranging from the Gandone Aswan, which has a compressive strength to 180. We also have an Imperial Red, which has a compressive strength to 260 megapascal compressive strength. The lowest we have right here is Karna Grey, which has a compressive strength of 147. We also have a wide range of density. For instance, Imperial Red, which has the most compressive strength, actually has the lowest density of 163 or 1630 in fact, and it also costs, there is a wide range of costs per meter square. For instance, the Rosa Marwa is cost 600, the Sharara Brown costs 800, so that cost quite vary as well. The uses in fact also varies. We have construction walls, fountains, fountain counters, interior and exterior, construction stone, and many other uses as well. Now, from where to get the products in Egypt? From where to buy them, to install them in our homes? Well, there are a lot of places. As I said, it is a very commercialized product. One of the most aspects, well, You can actually get it by selecting a contractor, finding a contractor and deciding which sample do you want to use. Then the contractor actually goes to the supplier to buy from them. The suppliers can be either Shaqq Taban, which is the prime supplier here in Egypt, and quite frankly might be one of the cheapest places. Also we have other factories which is very popular, including the Georgia Abdullah factory, which is called the Marmonil. We have a Shuruk company, which is also a main supplier of marble and granite, and is located in Imtidad Al-Amal building in Maadi, Cairo. We have Sinai company, and we have Wadi Nil company, and all of those are very popular companies that supplies a wide range boost here in Egypt, and quite frankly sometimes export a lot also. In order for us to be thorough in our investigation of the material, we have selected a factory for us to visit, and that factory was a Marmonil factory, or as it is also known by the George Abdullah factory. It is one of the biggest factory here in Egypt, and we actually was able to witness the entire manufacturing process of the material. And it goes as follows. First, the material is dug out of the mountain in the form of huge blocks of granite or marble. The blocks are then carried to the factory on a highway truck. And here where we actually have started to witness the process, the blocks are first unloaded off the trucks using huge computerized cranes, which actually goes from one end of the building to the other. It just goes a long way. Well, first of all, the crane goes down. It is able to move up and down to actually tie up the block or tie up the block and go up to move it up, and then the crane can move forward and backward to adjust the coordinates properly, and it can move to the left, to the right, to be able to store the block anywhere on site. Now we are faced with a question: is the material needed right now, or is it not? If it is not needed, then the material is just stored on site using the crane, which has access to every spot on the site. Or if the material is needed right now, then the block is placed on the machine. Also, if the material is then needed, then the crane take it from the storing spot to the machine. So the machine is called the cleaning machine or مكنة النظافة, and that machine basically remove any unwanted material area in the block and makes the block square, or as they call it, تربيع البلوك. After my block اتربع, it's time for it to be moved to another machine. That machine is called مكنة النشر. It actually starts to divide the block into equal parts or equal thickness of layers, and these layers are commonly known as طاولات, and it is very important. The machines contains a lot of cutting edges or knives that are equally spaced from each other. The block is put under it, and then the machine starts cutting through the block using water and very sharp edges and a very computerized, very machinized cutting knives. Then a طاولات are moved using a crane or a moving raft like to another machine, which is called the galaya, for polishing. So what is a galaya? A galaya is a polishing machine, because when the marble is quarried or after it is اتربع and اتنشر, it actually doesn't have that smooth shiny texture that we all witness and love. It actually has that rough texture, very dull texture. So we put the tawla at one side, and it goes through several polishers and several texture surfaces to make it shiny and polished, and it comes out finished on the other side. As we can see, the finished product appearing, and it is used in like some device that actually stuck to the polishing surfaces, and it moves it up and stacks it with the others. And then the tawlat are loaded on trucks using cranes or manpower. As you can see, a single tawla actually took like 3 to 4 men to load it up, so they are very heavy, and it helps when you use the crane, even if it is for assistance. Here is a video that explains the entire manufacturing process of marble and granite. It shows you the entire machinery that goes into the production line and how they are working. You can see it live, you can see it right there, how they are working. It's very nice video. It is very detailed, it is very thorough in explaining that aspect. We would have loved to show it to you right now, but it is very long video that we not very long, it's actually 15 minutes, but since we don't have enough time, we recommend that you watch it. It is very nice video that will help you a lot in understanding that. After witnessing how the material is manufactured, it was time to see how they are installed. In order for us to be thorough in that aspect as well, we have decided to visit a new site. In fact, we have visited two new sites. Both of them are actually apartment buildings inside Hadar al-Ahram compound. First of all, the client contacts a contractor who usually is the owner of some sort of ورشة رخام granite, who buys the tawlat from a supplier like شقة تابان or George Abdullah factory or any other. Then the contractor takes those tawlat to his workshop and start cutting them to whatever sizes or shapes needed on site. For instance تربيعات 60 في 60 or تربيعات 45 في 45 or نص تربيعة, which is basically an isosceles triangle, or whatever shape, octagonal, rectangular, with whatever sizes, whatever it is desired and wanted by the client or the architect. Then the marble or granite are transferred to a site using small trucks, usually نص نقل. Then it depends whether it is wall cladding or flooring. First of all, with the wall cladding, so first things first, we شد الخيط. Basically, we put the thread from one end of the wall to another to manage the horizontality. Then we start stacking the tiles on horizontal aspects. We make sure they actually aligned with that thread. Then we start stacking the tiles above each other, and we use a water balance to ensure that they are vertical, to ensure their verticality. It's important to know that the walls are actually not plastered, they actually just put on the red brick. There is a gap that is intentional while stacking the wall. The gap exists between the tiles and the wall. The tiles, this gap is used to pour gypsum and mortar to bind the material to the wall in a process called the السقية. As you can see, the gap means there is nothing to hold that tiles in place, so we use another quality control method, which is robotic gaps. As you can see here, the robotic gaps, we actually bind the tiles together to make sure that they don't shift or fall off after stacking them neatly. So as you can see, we have three quality control techniques. First of all, the pulling of thread or شد الخيط. 2, robotic gaps. 3, the water balance. So here you go, that's how you create a wall. Now it's time for us to understand how to create a floor. We visited another site, we have interviewed the engineer and the workers, and we have known what is the process. First of all, we spread the floor with sand to overcome the irregularity of concrete board and to maintain the level or shape of the flat or the apartment. Then the thread is pulled to check the axes and figure out the key tile. The key tile is basically the benchmark or the first point or the first tile to be put on site. That tile is extremely important to place, extremely accurate, because if it is accurate, then the entire project will go smoothly. If not, it goes horribly, because then we have a lot of problems that we need to manage later. So we manage the thread accurately to manage where is the first tile to be put. As you can see, the project is actually quite ahead. As you can see, there actually the tiles has been put, so we haven't witnessed the process of putting the key tile on place. Then the mortar is mixed. After the key tile is placed, we start placing the other tiles next to it, and we use a water balance to manage the horizontality and make sure that every tile is level and every tile is right next to each other without being shifted up and down, and they are at the right place. And until we finish, some contractors actually might buy unpolished tile, so we need a galaya. This galaya is not like the one in the factory, which is a huge machine. It's basically some sort of a cart with a polisher at the end. It rotates and it makes the surface shiny, and in process called the gali. Here you go, that's how you make it. And now it's also very important to acknowledge the credibility of the project. Therefore, here are the references that we have used to gather the secondary information that we have obtained from other sources, including the introduction and the other structures and references and standards. Now at the end, we want to thank you for your listening. We want to thank you for your time. We want to thank you for your participation in our project. And well, thank you again.